All right, so in the last video, we talked about the discriminant. And so remember the discriminant is b squared minus 4ac. And the discriminant is used to determine how many solutions you have and whether or not those solutions are real or imaginary. Now, we also discussed that discriminant was a small portion of the quadratic formula. And so the quadratic formula is what you actually use to find the solutions. So the discriminant tells you how many and if they're real or imaginary, but the quadratic formula tells you exactly where it crosses the x-axis. All right, so remember, this is what represents the x-intercepts on a graph. So if I did all of this work and I found, the solutions were -4 and 2, then I would expect a graph that maybe did something like that because it would cross at -4 and +2. Okay, so again, the discriminant tells you how many and if they're real or imaginary, but the quadratic formula tells you exactly where does it cross. All right, so again, you do need to be in standard form. All right, ax squared plus bx plus c. Typically, you'll see this where they're set equal to 0, and that's because you're actually solving. You're trying to figure out when you solve, what is the x value when the y value is equal to 0, because that would be the x-intercept, right? All right, so, but sometimes, depending on the textbook or whatever, sometimes that 0 is not there and they're still asking you to find the solutions. All right, but either way, all right, you do want to make sure that you are in standard form, and then you would label or identify your A, your B, and your C, and then you're substituting it in the formula. All right, so if you looked at the first example, A is 1, B is 6, and C is 5. So if I substitute into my formula, I'm going to have x equals -b, and I like to think of this as opposite b. All right, because if you had -b, like in this case, b is 6, right? So if I had negative b, well, -6. Then instead of being +6, it's -6. But what if I had, what if b was -2? Well, a negative b would be a -2, which would make it +2. So essentially, the signs are just changing when you use or when you have a -b. It's like opposite b. So for me, when I do my work, I usually just think opposite b. Okay. Now, some teachers are a little bit more sticklers for actually writing that out. -4, negative with a parentheses with a 3 or something like that. Okay, but I typically use opposite b. So in my class, I accept that from my students. All right, so I'm going to have a -6 because opposite b is -6 plus or minus the square root. B squared would be 6 squared minus 4. That's part of the formula. A is 1, C is 5, all over 2A, 2 times 1. All right, so then because you're dealing with real and imaginary solutions, to me, I like to piece it out a little bit more because I like to see what's my discriminant, and it kind of helps me make predictions. But depending on the calculator that you have, you could put this all in at one time, except you typically can't do plus and minus at one time. You'd have to type it all in with a plus and then do it all again with a minus. All right, but I'm going to piece it out. So I'm going to have -6 plus or minus the square root of something over 2. All right, so in my calculator, I'm going to figure out, well, what is that discriminant portion? All right, so I'm not going to type the radical in because I want to see the actual discriminant. So I'm just going to use parentheses 6 squared minus 4, A is 1, and C is 5. And I got 16. Well, right away, that tells me something about my problem, right? I know that because my discriminant is 16, remember that's the discriminant part, b squared minus 4ac. I know that I'm going to get 2 solutions and that they're going to be real. All right. Now, you can keep piecing it out if you want to. I don't piece it out. I go ahead and just let my calculator do this for me. All right. So in the calculator, I'm going to do one with a plus and one with a minus. All right, so I'm going to do it once with a plus, once with a minus. All right, so I will put n over d right here, -6 plus the square root of 16, which I know that's 4, but it's just like one more step to have to do that. I just type it like I have it, over 2. And I got -1. So one of my solutions is -1. Now I'm expecting another one, right? So I'm going to do it again, n over d, -6 minus the square root of 16 over 2. And I get -5. So those are both my solutions to my function. All right, so I did it in my calculator once with a plus, once with a minus. All right, now if you don't have a calculator that has the n over d feature, you may have to kind of piece it out little by little until you finally get your answer. All right. So for the second example, A is 1, B is -4, and C is +4. So I'm going to substitute into my formula, x equals opposite B. Well, B is -4, so opposite B would be +4. Plus or minus the square root, B squared, so -4 squared, minus 4. A is 1, C is +4, all over 2A. So 2 times 1. All right, so I'm going to piece this out a little bit. So I'm going to say 4 plus or minus the square root of something over 2. All right, because I like to type in the discriminant portion. All right, so I'm going to have in my calculator a -4. That should be a -4. There we go. All right, so parentheses with a -4, close it, square it, minus 4. That's part of the formula. A is 1. C is +4. And I got 0. All right, so my discriminant is 0. Well, that tells me something about my problem, right? I know that if the discriminant is 0, I'm only going to get one solution. And that's because the square root of 0 is 0. So you can kind of save yourself some time there and know that if you add 0 to 4, it's 4. If you subtract 0 from 4, it's 4, right? And then we're left with 4 over 2, which is 2. All right, so 4 over 2 is 2. And we only have one real solution. All right, that's why I like to piece it out a little bit, because the discriminant really does help me. Whoops, I don't know if it'll let me grab what I really want to grab, but all right, well, I'll make it work. All right, trying to make sure I have room for the next problem. All right, well, anyway, the last problem that I have, the A is 2. Whoops, move it over a little bit. The A is 2, the B is -3, and the C is +4. All right, so I'm going to substitute into my formula, x equals opposite B. Well, B is -3, so that would make that +3, plus or minus square root. B squared is -3 squared minus 4. A is 2. C is +4, all over 2A, which is 2. So I'm going to have 3 plus or minus the square root of something over 4. So in my calculator, I'm going to figure out the discriminant portion. So remember, with the discriminant portion, I'm not putting the radical, okay? So I'm doing parentheses with a -3 squared minus 4, parentheses with a 2, parentheses with a 4. And I get -23. All right. So I have a negative discriminant, -23. So that tells me that I'm going to have no real solutions, but I am going to have two imaginary solutions. All right. So what you have to remember is that when you have a negative under the radical, remember that you pull out I. All right. So when we pull out an I, we end up with 3 plus or minus I square roots of 23 over 4. All right. And that is two real, or not two real, sorry. That's two imaginary solutions. It's two solutions because you have the plus and the minus. Okay. So this is a good solution. It has two imaginary solutions. Sometimes you'll see it broken apart though. So I just want to kind of show you that. Sometimes you'll see it written like this: 3/4 plus or minus I square roots of 23 over 4. So sometimes they do bust it apart because it sometimes helps you reduce, maybe this fraction reduces, but maybe this one does not. Okay, so sometimes you will see it broken apart. Sometimes you'll see it kind of all pushed together. Sometimes you'll see it where they'll do 3/4 plus blah, 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 and then 3/4 blah, 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 like completely separated out. All right, but that is the quadratic formula. I did want to show you one more thing, just in case you get an answer that looks like this. So what would happen if you got something like this? 4 plus or minus the square root of negative 32 over 2, something like that. All right. I would know because the discriminant is negative that I would have imaginary solutions. But depending on whether or not you have a calculator or not, you may have to break that down, right? Now, the calculator that I have up here, I can do the square root of 32, but if I did the square root of negative 32, it gives me a domain error. That's because it's imaginary, and this particular calculator doesn't handle that, okay? So it's not that I'm doing it wrong, it's just I can't take the square root of a negative number in here because it's imaginary. So if you get those types of errors, then it's not that you've messed up, it's probably because you're dealing with imaginary solutions. All right, so you do have to piece it apart. So instead, I could do the square root of positive 32 and get 4 square roots of 2. But because it was negative, I know that there has to be an I sandwiched in between, right? Okay, now if you have a calculator that does this, then that's fine. But if not, you'd have to piece this out on your paper. You'd have to say, okay, what's the square root of 32? Square root of 2, square root of 16. 16 is 4 and 4, right? So I have a pair of 4s and then a square root of 2. So 4 square roots of 2. So if you had to, you could do all of that by hand. All right. But if you can do it in the calculator, even better. All right. So this would equal then, let me go back, sorry. Okay, this would equal 4 plus or minus 4i square roots of 2 over 2. All right, so the square root of 32 was 4 square roots of 2, but because it's negative, we have to put the I in there. Now remember, the I gets kind of sandwiched in the middle because we don't want to put it at the end because somebody might mess up and think it's under the radical, right? So the last thing we would do is simplify this, all right, because 4, 4, and 2 are all divisible by 2. So think about this as like 3 different terms, right? 4 divided by 2 is 2, plus or minus 4i squared to 2 divided by 2 is 2i square roots of 2. And those would be the two imaginary solutions. Again, you could break it apart and have 2 plus and then 2 minus, okay? I do want to caution you that a lot of people try to do this. They try to divide 2 by 2 here, but this square root of 2 is a part of this whole entire term. Can't divide the 4 by 2 and then turn around and divide a radical by 2. Like that's like double dipping, okay? Plus, you can't divide the radical by a whole number, okay? Now, if this had had a square root of 2, then you might could have done some stuff like that, right? But it does not. All right, so this is your final answer. So that's how you deal with the quadratic formula. So remember, the discriminant tells you how many solutions you have and whether or not they're real or imaginary. But the quadratic formula is the formula that tells you exactly where it crosses the x or the x-axis.